Hello everybody. We're now going to look at 1.4 in Hartshorne. There is only one new statement that we need to prove. He says, furthermore, an algebraic set is irreducible if and only if its ideal is a prime ideal. So let's first write this down. We are going to assume that our irreducible set is called Y. So Y is irreducible if and only if its ideal, I of Y, is prime. Okay, proof. We'll assume that we have Fg in I of Y. Then Y is in the zero set of F times G, right? But the zero set of F times G is the same as the zero set of F union the zero set of G. Okay, so we can express our irreducible set Y in the following way. This is the same as the intersection of Y with Z of F union the intersection of Y with Z of G. But now look, these are both closed sets that we have in this union, and we have assumed that Y is irreducible. So without loss of generality, we can conclude that, for instance, this set Y intersected with Z of F has to be all of Y. So Y is a subset of Z of F, and this of course means that that F is in the ideal of Y. And oh yeah, that's what we wanted to show. We wanted to show that the ideal of Y is prime. And now we have concluded that assuming that F times G is in I of Y, we have to conclude that F is in I of Y, which we have just done. So we have shown that I of Y is prime. Now for the other direction. So this was the first direction. Now we assume that P is prime. And we want to show that Z of P is irreducible. Okay. So assuming that we have written Z of P as a union of two closed subsets, so Z of P is Y1 union Y2, we need to show that either y1 or y2 or both of them is indeed all of z of p. This would show irreducibility. Okay, since z of p is y1 union y2, p has to be the intersection of I of y1 and I of y2. So these are the polynomials that vanish on y1 and y2. But now p is prime. Which leads to the conclusion that p is either I of y1 or I of y2. So without loss of generality, let's assume that p is equal to y1. So z of p is z of I of y1, which is y1. So indeed, z of p is irreducible, and this concludes the proof.